Hello and welcome to Honors Function. This is the fourth and the last video of the series on function, the introductory series to the second unit. In this video, we will generalize the concept of an x and a y-intercept that we have seen previously while looking at linear equations. So, if you're given a function y equals f of x, what do we call an x-intercept of the function? It is a solution of f of x equals 0. Okay, so you set y equal to 0, and you solve the equation. That's for the x-intercept. What do we call the y-intercept? Well, the y-intercept is just f of 0, okay? So the first thing we say right here is that a solution of the equation, this equation may have no solution or an infinite number of solution and anything in between, infinite number of solution, okay? So, and anything in between right here. While the f of 0, well, maybe it doesn't exist or it has one value, okay? But you cannot have more than one value. So at most one value, and here any number of value between 0 and infinity. Graphically, well, graphically it's pretty simple. Graphically, an x-intercept is the place where y is 0. So this is an x-intercept. Here we go. Another one. Here we go. Another one right here. What is the y-intercept? Y-intercept would be this value right here where x is 0. Okay, let's go over some problem. Before we do this though, I want to make sure we understand the language. So an x-intercept is a point. Okay, so be careful here. I'm going to write it here. An x-intercept is a point. So suppose it is like x naught 0, okay? And I'm gonna be talking about this point like right here. Let's talk about this right there. This is x naught 0. It's a point, okay? We also say a 0 of f, okay? We also talk about the zeros of f. Well, the 0 of f is just the x coordinate, okay? That's a 0 of f. It's a value that makes f equal to 0, okay? So x-intercept is a point. 0 of a function is a value that makes x equal to 0. We also say, instead of 0, we sometimes say a root of f, okay? So you need to be familiar with all these different terminology. X-intercept, 0, root. This is a point. These are values, okay? All right, let's go over some examples. I'm going to let you deal with example 1. I'm going to take example 2. I want the zeros, so I'm just going to give the value, the zeros of f. So I need to solve the equation f of x equal to 0, okay? So how do we do this? Here's the expression for f of x. I'm going to factor it, and I'm going to do a grouping, okay? So you factor by grouping. Hopefully you remember the process. Factor by grouping. What does it mean? In this case, I'm just going to group these right here and these, and let me see if I can take something out. So let me try 3x squared out of the first two, and I will have 2x minus 1. And on the last two, I'm going to take negative 12, and I have 2x minus 1, right? Negative 12 times negative 1 plus 12. Now, this is not factored, right? It's partially factored, but it's not completely factored. Now, what I can do is factor 2x minus 1, right? So I'm going to take 2x minus 1 out, right? I'm going to factor it. And it's times what? 2x minus 1 times what? Well, times 3x squared minus 12, right? Minus 12. Here we go. So I've written, I'm writing rather, I'm not done yet. I'm writing f of x in its factored form. So it is 3x squared minus 12 times 2x minus 1. Let's continue with 3x squared minus 12. Take a 3 out, and you're left with x squared minus 4, which is x plus 2 times x minus 2 times 2x minus 1. So I can really see clearly where my zeros are. The zeros are, okay, I have one at negative 2, another one at 2, and another one at 1/2. We can put them in a set like this. These are my zeros. It's the value that will make the function equal to 0. Okay? All right. So hopefully you remember how to group. I'm going to let you do example number 3, and I'm going to do example number 4. So example number 4, I want the x-intercept and the y-intercept. So in this case, I want to point. Hey, let's start with the easiest. Let's start with the y-intercept, okay? Y-intercept, what do? You're looking at g of 0. So this is 0 times what? Well, this is gone, and we're having a problem here. It's not defined. Well, guys, you got to be careful. I told you the y-intercept may not exist. You have a radical here. So the first question you should ask yourself always is, what's the domain of G, right? That's the first question. So let's think about it 1 second. We want x squared minus 3x minus 4 to be positive or equal to 0. That means we want x minus 4 times x plus 1 to be positive or equal to 0. So I got a 4 right here and a negative 1 right here. And so my domain, the domain of G, is anything, it's a parabola and it's concave up, outside the root. Anything below negative 1 included, or anything above 4 included. That's it. This is my domain. 0 is not in D of G. 0 is not in D of G. So you're not going to have a y-intercept. How about an x-intercept? Well, check it out. Look, if you want to solve the equation g of x equal to 0, what is g of x? G of x is a product of two quantity, right? So you have x times square root of x squared minus 3x minus 4, that is equal to 0. Now, when is a product equal to 0? When one of the quantity is 0. So you want x to be 0, or you want the root to be 0. So you want square root of x squared minus 3x minus 4 equal to 0. This is not in the domain, so that's not going to be an x-intercept, okay? How about this one? Well, this is 0 at the boundaries of the domain. You need x to be negative 1 or x to be 4, and these will be your 0. Therefore, the x-intercepts are negative 1, 0, and 4, 0. Don't forget to give them as point, please, okay? All right, let me do number 5 now. So, in number 5, I want the zeros of the function g. Hey, the first thing I'm going to do right here is find my my domain. And before I do that, I can take a 4 out, right? 4x squared minus 36. Oh, sorry. If I take 4 out, that's minus 9. So I can take it out as a 2. Take it out of the root, right? And you have x squared minus 9. And this is positive outside the roots. So the domain of g is negative infinity, negative 3, union 3, infinity. This is my domain for g. Now, let's find the zeros. So you want to solve the equation g of x equal to 0. And so you have either x squared minus x minus 2 equal to 0, or the other one, the root, square root of 4x squared minus 36 equal to 0. Well, we know where this is 0. This is 0 at plus or minus 3. This right here factors as x minus 2x plus 1 equal to 0. So we would have x equals 2 or x equals negative 1. But none of these, this is not in the domain of g, and this one is not in the domain of g. Therefore, I only have 2 zeros, negative 3 and 3. That's it. Only 2 zeros there, okay? So domain of the function is very, very important when you're looking for the x-intercept and the y-intercept. You got to make sure the value that you find will be in the domain, okay? I'm going to let you do number 6. I'm going to do number 7. All right. Okay, first thing that we need to do right here is find the domain, right? Okay, now, for this domain, we want 2 minus x squared to be strictly above 0, okay? Don't say equal to 0 because you are at the denominator. And if you make the radicand 0, then you would have square root of 0. And that's fine. Square root of 0 is 0. But then you divide by 0, and that is not fine, okay? So we don't want to make it equals strictly above 0. This is pretty simple. 2x, and then 1x. And then we want minus 2 and plus 1. minus 2 plus 1, yep, negative x, okay, here we go. So we got a negative 2 from this one, and we got a 1 from this one. And so the domain of the function that I called L is, and I want to be careful right here, between the roots, okay? It's concave down, right? It's concave down, so to be positive, you have to be between the roots, and I'm not taking the boundaries, so it is between negative 2 and 1. That's it. That's my domain. So this is where I'm going to be looking for my x-intercept. Yep, x-intercept right here. Oh, let's get the y-intercept first. So what's going on for the y-intercept? L of 0, so that's gone. This is gone. This is gone. So 0 over something, that is going to be L of 0 equals 0. And actually here, here's a y-intercept and also an x-intercept. This is both a y-intercept, the y-intercept, right? The y-intercept. But this is also an x-intercept, right? It's an x-intercept. Let's see if we have other x-intercept. So L is a fraction, so you want to solve L of x equal to 0. L is a fraction, okay? When is a fraction equal to 0? So this is what I'm asking you right here. If you have a fraction, when is a fraction equal to 0? Only when the numerator is 0. That's it. That's all, okay? So to find the other x-intercept, if I have any, I need to solve the equation 2x cubed minus 3x squared minus 5x equal to 0. So let's factor this. So the first thing that you're going to do is take an x out and then try to factor this. So I'm going to have a 2x here probably, if I can. And if I cannot factor, not a big deal, okay? I'll complete my square or I use a quadratic formula. I want a 5 and a 3, so probably the 5 right here, the 1 right there, and I can make a 3 with a 5 and a 2, and I need a minus 3, so that's a minus 5 and a plus 1, and that should work. So I have x equals 0, we already get this one, x equals 5 half, or x equals, so or in between right here, or x equals negative 1. Now let me see, my domain was anywhere between negative 2 and 1, okay? So this is discarded, 2.5 is not, and I'm only, yeah, the negative 2 and 1. So here are my x-intercept, 0, 0, we already said we had this one, let's not rewrite it. Negative 1, 0 is another one, okay? So 2 x-intercept and 1 y-intercept. All right, let's do example 9, and we're done. So guys, in this example, you're going to have to be used to looking at function numerically. This is a numerical approach of a function, okay? We write all the value of the function in a table. So let's find the x and the y-intercept of these two functions, okay? So here, how do I present this? F of x, okay, here we go. Let's do a table to present that. It's going to be faster. F of x, g, or rather f and g right here. These are my function. And I'm going to write here the y-intercept. So I need to write a point, right? And here I'm going to write the x-intercept. I may have one, I may have none, I may have more. Okay, y-intercept, you're looking at x equals 0. So the y-intercept of f is 0, 0, which is also an x-intercept, okay? And the y-intercept of g is 0, negative 3. Here we go. The x-intercept, I want y equal to 0, so I want f of x equal to 0. So I'm looking at this column, and oh, right here, I have a y equal to 0. So another x-intercept is negative 2, 0. And I'm going down, I got this one. Okay, that's only 2. Of g, I got one right here, so I have negative 4, 0, right here. And this one right here, 1, 0. Okay, that's 1, 0. All right, this video hopefully is short and sweet, but it is technical. You have to be able to solve equations, okay? And don't forget the domain. Whenever you're looking for a y-intercept or an x-intercept, you got to make sure you're in the domain of the function. Thank you for watching.